Hi, this section is fully dedicated to Dagster. We'll be showing you how to deploy your DLT pipelines with this orchestrator. So very quick, if you haven't already, please run the code in the case study that we showed you in the previous section, because we'll be deploying that very same pipeline in our subsequent demo. Of course, to do this, you'll need a GitHub account and GCP account. All the details are provided in the previous section. So for this section of the course, we'll give you a quick intro to Dagster, including some of the key terminology and concepts, and then we'll transition to talking about the DLT and Dagster integration and go over why one is needed in the first place. And then we'll get to the actual coding. First, we'll show you how you can deploy your DLT pipeline in Dagster locally and then in the cloud. So Dagster is a pretty modern data orchestrator. It's unique in the way that it's centered around the data product itself. In that, I mean, while some orchestrators might answer the question of what task to run and when, Dagster is more concerned with, what data products are currently in the system. When were these data products updated? What upstreams are these data products dependent on? And so on and so forth. You'll notice later on during the demo that Dagster has a really great UI that has data governance tied into it. So if you're interested in a solution that has, data lineage that shows you what comes from where, if you want to be able to easily see the schemas of your resulting from your pipeline run, and if you want to see, how many rows have been collected from each iteration, then, Dagster has a great UI for this. Now let's talk about some key terminology. If you go to the Dagster docs, you'll see a glossary filled with terms, but for this course, just these three terms will suffice. So first we have assets. Assets are the data abstraction that Dagster uses. So an asset in Dagster could be used for representing files, data sets, even machine learning models. Then we have definitions. So you can think of definitions as a manifest, which gives Dagster all the information it needs to process the assets. And then the third term is just materialize. So this is a verb for basically just running the code that produces the assets. Now let's actually translate this in DLT context. So in DLT, our assets are just going to be basically DLT pipelines wrapped as assets. Our definitions is basically going to be the file that contextualizes our DLT pipeline run. And then in our case, materialize just means running the DLT pipeline. So here, I just wanted to show you some Dagster syntax. In this code snippet here, we are defining a very simple asset here. As you can see, we're using an asset decorator to denote an asset. Within the function itself, you can see that in the parameters section, we are able to provide context. In this case, we're providing it with asset execution context. So this is basically an object that you can use to get information on a specific run. So as you can see here under this function, we're actually using this object to get the run ID. So that's how you define an asset. And in the UI, this is how your assets are visualized. As you can see, these rectangles denote individual assets, and the arrows from one asset to the other denote dependency. I've talked a bit about assets and definitions separately, but let's talk about how they work with one another, synergy. And to do that, I think it helps to use a simple analogy. At least that's what helps me as a visual learner. We're talking about orchestrators, so what better analogy than an orchestra? So of course, in an orchestra, in an oversimplified explanation, you have a conductor that has a musical score that they use to basically guide a group of musicians to make sure that they perform in harmony. Now, how do you link that to Dagster? Well, let's start with assets. So assets answer the question of what data products exist, and you can define them in Python modules. It can be one file, it can be multiple. So assets in our analogy are the musicians. They all perform a specific task or job. but they are pretty independent to one another. One asset isn't going to know what the other asset is doing. So on their own, they aren't going to be able to run properly together in unison. Then we have definitions. Definitions answer the question of how the assets should be run. Unlike assets, which can be, in as many scripts you want, definitions are always represented in one script in Dagster. And in definitions, you provide all the information that Dagster needs, such as what assets are in the system, what resources are needed to run the assets, and any other additional features, such as, the number of workers or, what type of schedule you want to configure, i.e., how frequently you want to materialize a certain asset. So, going back to our analogy, Dagster, the orchestrator, when given a Dagster project, will look at definitions.py, which serves as the entry point. Definitions.py basically has all the information on the assets and how to run them that Dagster can use to then materialize these assets successfully. I hope that kind of helped you understand the relationship between assets and definitions. Dagster is pretty unique in the way it structures its project. Normally in orchestrators, you provide the information on your tasks as well as the instructions for running this task in the same place. But Dagster isolates the two from one another, and this is pretty good for making Dagster projects simple and scalable. After all, no matter how big a project gets, there'll always just be one definitions file. Up to this point, whenever I spoke of assets, I was actually referring to native Dagster assets. However, in our demo or for our deployment of DLT pipelines, we will not be using native Dagster assets. And I'll take some time to tell you why. So let's first talk about what DLT does behind the curtain when it runs a DLT pipeline. A DLT pipeline, in the eyes of DLT, can be broken down to different stages. We have extract, we have normalize, and we have load. For each stage, you have, multiple resources. So when you run a pipeline, traditionally, the first thing you do is you extract your data for all your resources, then you normalize your data for all your resources, and finally you load the data for all your resources. And the cool thing about DLT is that you are able to configure and customize different stages of the pipeline run, as well as give specific instructions for different resources, which can be very helpful for customization. However, when you were to represent this DLT pipeline solely as a native asset, you lose that customization. It basically just becomes one big blob of code that you can run, all or nothing. While that in itself is feasible, you can still run your DLT pipelines, you leave a lot on the cutting board. So let's talk about some of the shortcomings of using native Dagster assets. Well, the first, of course, is, like I said, the lack of flexibility. You can only run your DLT pipeline as a whole. And you also have no ability to have selective runs. For example, let's say that, out of 4 resources, you want to run your pipeline just for the third one. Well, in this arrangement, that's not really doable. You would have to run the entire pipeline, i.e., all 4 resources, just to get that one run that you want. And finally, you don't have access to parallelization. Parallelization is great in that it helps you process multiple resources concurrently, which can save you a lot of time. And it's also a good way to, leverage the multiple cores that Dagster offers. However, by representing DLT pipelines with native assets, you lose the ability to do that. Thankfully, there is a very simple solution to this in the form of an alternative to native assets, which are called DLT assets. Now, as the name suggests, this is basically just an integration of Dagster and DLT, basically assets that are dedicated to DLT pipelines. So I want to quickly show you what that would look like in application. So this is just a code snippet that I got, again, straight out of the Dagster documentation. And it's very similar to, the definition of a native Dagster asset. Of course, we have our function, which uses a decorator. Instead of an assets decorator, we use a DLT assets decorator. And within this decorator, you are providing the DLT source and the DLT pipeline. Of course, the two main ingredients needed to run a DLT pipeline. And then within the function itself, if you look in the parameters, we provide two types of context. We are providing the asset execution context, which we already spoke of before, and then the Dagster DLT resource. We'll talk a bit more about what that is later. But this is a pretty important component for using the DLT assets to run our DLT pipelines in Dagster.